Welcome to the Talking with the School of Transportation podcast, presented by Centennial College. With your hosts, Ian Campbell and Harnett Gill. Let's get into it now.
Welcome back to the Talking with the School of Transportation podcast. I'm Ian Campbell, and I'm here with Harnett Gill and Jason D'Amico for his third appearance on the podcast.
Welcome back, Jay.
Thank you very much, guys. Appreciate it.
You've been a much requested individual to return back.
Yeah,
to the
I was
podcast
forced
stage.
to come back. You're right. You phrased it differently, but yeah.
You down the hall. It's like, let's go for lunch. Why am I here?
Yeah. So we're going to get into discussing master cylinders.
Yeah,
So-
well, we're kind of on summer break right now, which is kind of nice. And we made Jay hop on his motorcycle and
Yeah.
and
I
fly
feel,
on
I
down
feel
to
that none of my
college.
answers need to be at all correct at this point in time. It's vacation.
Okay, we'll see how this
vacation
goes.
mode? Yeah, let's see how
it's
this is
vacation
different.
mode answers.
Yeah. What have you been up to on your kind of break or downtime?
Obviously, just primarily focusing on how can I be better for the students in the fall.
We love to hear that.
Working on my lessons, my lectures, updating my PowerPoints.
A lot of zombies.
Little bit of Xbox has snuck in there, yeah. Not going to lie. There's been some Xboxing because you've been with me, so I can't lie.
We have played a fair bit of zombies, yes.
No, nothing, man. You don't get much done. And you get older, all the time off. It disappears. If I cut the lawn twice this summer, like that's a win.
Wow.
In my books. Yeah.
Oh, wow.
You're that neighbor.
Yeah, totally. No, I just don't need to. Like, if my wife cuts it. But, I'm saying, like, if I can get out and do it twice, I look good. Just assert myself in the neighborhood.
That's great. Today, we're going to get back into some tech talk, really, because we've been kind of interviewing students and we were at a job fair or a skills competition and stuff like that. So we wanted to get back in talking about some components and hopefully helping people learn with that. And I sat in one of your labs on master cylinders, Jay, and I was just blown away by the way you were able to express it all. And I know that you were kind of frustrated that day and fiery, so I thought maybe if we can sit him down in a nice like white room with padded walls, he'd be
Special jacket.
Yeah. I do like the jacket.
he'd be able to explain it even better. So I just would like to do that. I think it's one of the more important topics, really, when we talk about hydraulics and brakes and how that master works.
Yeah, because really it's kind of one of the areas of the vehicle that hasn't evolved much in the last 50 years.
Maybe adding a second circuit, but
but the core fundamentals, the hydraulics, like that's unchanged.
Mm-hmm.
Yeah.
Yeah. And Harnick, you teach SSB 1 a lot too, which is master cylinders. So I think you can throw in some good stuff, and I'm ready to learn. So let's get into it.
All right. So why don't we start off, first of all, you mentioned that, Jay, you were getting a little frustrated with the students. Is that right?
No, it wasn't with the students. It was, I had a 4-hour lab that day, and my structure for that lab was like master cylinder overhaul and rebuilding. And there was a scheduling conflict where, like, last minute, I was told I can't be in the lab. Yeah. I need to use a theory classroom. So it was kind of a week 4 last week with the students. They need this before their final exam in 3 days. So it was kind of on the fly. I had to grab whatever I thought I would need. I wasn't allowed in that lab area that day. Yeah. So I had to take tools with me, hones, the master cylinders, obviously, like whatever I could. And I just improvised in a theory classroom as best I could.
And I sat in it, and it was awesome. So I'll give you credit to that.
Yeah, it wasn't the best for the students. Like,
sure,
we were limited, but you make the best of it, right?
Well, you get by.
Yeah, you got by, exactly.
Mm-hmm. Okay, so what when you have the students in there going through with the master cylinders, what do you do with them?
So I'm trying to think, because depending on, our timetable and our structure, it's asynchronous sometimes. So I think before I teach any of the theory of operation, I believe I do my lab first. With a lot of things we teach, if I can kind of get them hands-on, seeing, touching, experiencing, the theory tends to flow a little bit smoother.
That's so funny because a lot of faculty like to have the theory before the lab, but I think it's because of the way you can teach and your experience level with it. You like to give them a part and go, hey, look at this, and then the theory just kind of flows after the fact.
Well, it's kind of nature of the beast, right? Like if you look at how do our students, and probably us included, true. How do we learn best? We're the kinetic visual learners. So to sit there and bust out a lot of theory, it goes in one ear, out the other. But to let them actually see something first, it tends to really just compound the learning.
Even if they don't know what they're looking at.
It's the preferred method.
Exactly.
It's just,
they still see something that they can relate to when they're in
It's
theory.
that natural inclination to, I touched it, I saw it, and now I can visualize the theory a bit better.
Yeah.
And I think that's what I like about apprenticeship. At least theoretically, most of the stuff we're talking about, they should have seen in a shop so that they have, and you see it all the time, the students who understand the concepts better are the ones who are touching and feeling and working with this stuff in the shop, right? So they're actually dealing with it, and I find that makes a huge difference in understanding.
Yeah, even if they're, and odds are, if they do have some of that experience with the components, they probably don't really understand the operation or know what it is. They're just doing like a simple install.
Sure.
But that's something to work with.
It gives them a visual. It gives them, I've changed this, but I never really knew what this did.
But they know some of the procedures involved outside of like torquing it to a spec. They're like, oh, we had to bleed. We had to remove air from the system. Like that's tangible. I can work with that.
For sure.
That'll relate better to the theory.
Yeah.
By far.
So when we talk about master cylinders, I think we have to preface hydraulic theory a little bit before that. Is that where you would start, or would you get them on the component
So
first,
what I would have done is in a previous class, I would have done like my Pascal's lesson.
Okay.
I would have started with hydraulics. And
Can you just quickly explain what that is?
Yeah, like Pascal's law.
Yeah.
So we got a lot of these, and I always say, when guys are really smart, they get a triangle and their name attached to it, right? There's ohms, there's watts, and now here's another guy I went to high school with, Pascal.
Yeah.
So a lot of the students, they've been exposed to Ohm's law, probably in high school, even in a bit of physics or whatever class. But their understanding of that triangle is, well, it's purely math equations, and if you have two given, you can find the third unknown. And I try to say, no, guys, this triangle isn't a fast way to remember math equations. It's the understanding of how the three factors in the triangle work together and relate. The math just proves the concepts. And that's for everything. I always find that's the biggest hurdle is the math isn't the math. Like, and I'll often say, at the shop, do you see me running around drawing triangles and scribing equations? And they'll say no. I'm like, okay, then why is it mandated that we spend so much time teaching it to you? And they have no answer. And I say, well, guys, when you ask me, hey, I took my stock master off my vehicle and I put on a larger master. Right there I stop and I say, well, by larger, what you mean is the piston has a greater surface area. And they go, oh, okay, I guess so. Yeah, a bigger piston. I go, okay, so what's your question? And they're like, well, so I got the bigger master on. How's that going to affect my brakes? And then when I give them a verbal answer, I'll say to them, like, do you know how I got that answer? And they're like, well, you've done it so many times. You've seen it. You've memorized it. And I'm like, no, there's no way I could memorize that. What I do is I take very simple numbers and I run the equation in my head. And then I change what you asked me about. I change the surface area of the piston. And then I look at the resulting effect on mainline pressure.
Yeah.
I go, that's how I get that verbal statement. The math supports it. And some of them, you run through a bunch of examples and they really start making that connection.
Yeah.
But if you just bust up, here's a triangle, force, area, pressure, units of measurement, because I'm an imperial guy. So force is pounds, area is square inches, and then I show them the magic of pressure, pounds per square inch. That's where that comes from, the other two factors. But if you just start doing math equations, they don't see the connection.
For sure.
But so I'll draw a lot. Like I'll draw. I always pick easy numbers because I don't want the math to be the issue. I want the math to prove the understanding. So I'll do like 20 pounds of force is applied to a master cylinder of 1 square inch.
Sure. What
is the resulting line pressure? And they'll do the equation and it's 20 psi. And then I'll say now 20 psi is applied to a slave of 2 square inches. What is the resulting clamping force? So as I verbally say it, I'm constantly using the correct units to reinforce, force is applied to a master. Pressure is applied to a slave. Force results as the output from a slave, like trying to get them to understand. Because a lot of times they'll think force and pressure, they're synonymous. They're two words are the same thing. They're really not.
Yeah. So you're saying two terms, master and slave. And just to go in a little deeper, master cylinder would be the input piston.
Yeah.
Basically.
So we've got
and
our
the slave would be the output piston.
So what I'll do for definitions is once it ties into the math, I'll say, here's a master, and I draw a lot because nobody likes words, but we like pictures. So I draw a master with a piston, and then I'll have 20 pounds with an arrow applied to it. So as I draw and I say 20 pounds of force is applied, I'm drawing 20 pounds with an arrow into the master.
Okay.
And then I'll say, what is the resulting line pressure? And I'll draw an arrow coming out down the line that says 20 PSI.
Yeah.
So then I'll stop and I'll go, guys, can you give me the definition of a master cylinder? And I'll get, if they participate, I'll get some wild answers. I'm like, no, guys, the answer is in the drawing. And I don't want a long-winded paragraph. I go, look, what's going in? F. What's coming out? P. So literally my definition for master equals F arrow P.
Okay.
And I'm like, if this is an equation you guys can remember for the rest of your life, it's a definition. And they kind of like that. And then when we turn around and we go, like, what's a slave? I start getting calipers and wheel cylinders and cup seals and all these terms I don't want. I go, guys, look at the mathematical schematic.
Interesting.
What's going into a slave? Pressure is applied. Pressure goes in. What comes out? Force.
Yeah.
Slave equals P arrow F.
Okay.
And then I kind of bring it to the whole package and go, guys, can you tell me what hydraulics are by definition? And again, if they're on the same page as me, I'll get the answer, or I'll get these wild definitions. I'm like, guys, look at the whole thing. F went in, witchcraft and voodoo happened, turned into pressure, more witchcraft and voodoo, force came out.
Yeah.
So really the definition of hydraulics equals F arrow P arrow F. Sure. We are transmitting force across a pressurized fluid. No paragraphs, no words.
Yeah.
It's three simple equations, and that'll stick with them.
What a great way to think about that. I've never heard that nor thought of that before with the force and pressure. Like, that makes so much sense. It's just an easy movement, basically.
Well, necessity is the mother of invention, right?
Of course. Yeah.
When I used to teach the long-winded textbook definitions, it doesn't stick and it's not
100%.
usable.
Yeah.
I'm like, you know what? If I can eliminate words and just have almost like hieroglyphics an equation,
Go
and
back
it
to
sticks,
caveman era.
and it sticks, I'm all for it. Because again, can they take that away with them and apply it?
Yeah.
And if it works, I do it.
And it's that KISS analogy, right? Keep it simple, right?
Yeah, but
Stupid.
Yeah, silly.
That's awesome. And so then the slave would be that output piston, basically.
Yeah.
Input, output piston. And then, so that's kind of a really great sum up of the hydraulic system. How does the master kind of start that all off?
Well, so our master cylinder, like by definition, you look at the operator of the vehicle, your leg produces force.
Sure.
Right? So I stick in the same simple units of measurement, right? You make X amount of force with your foot. It's applied to a pedal, right? And then that pedal I would have previously taught already
Mechanical
leverage.
advantage. Yeah.
So then they know with levers can either make you stronger or faster. They can't make you both. And whatever you excel in, you inversely and proportionally lose from the other. So if a lever is set up to give me a mechanical advantage to double my strength, then the negative would be my speed is reduced in half.
Of course.
It's inverse and proportional. So either which way, you've got that lever assembly, 5-to-1, 6-to-1 is typical. Force is going in, force is still coming out. It's just getting multiplied. So now all that force, if it was level 3, I would include my boost unit.
Mm-hmm. Yep.
But if it's level 1, I leave the boost unit out. And I say, now all that force that came from your leg was multiplied. It's still force, and it's going into the master. And that master, with its witchcraft and voodoo, it's going
push rod seals and pistons.
yeah,
But yes.
yeah, it's going
Witchcraft.
Yeah. Well, sometimes I just speed it up, right?
Yeah.
I'll get into the
course.
details after they get the concept, and I'll be like, all that force applied to the master is going to get converted into hydraulic pressure and fed down to your wheel slaves, and then when they've got that down solid. When we're in lab, now they're going to see what's actually happening inside of the master, how it accomplishes that.
Yeah.
But it's very basic old concept. And it works. That's why we like it. It's reliable.
Yeah. Simplistic devices are the best, right? At the end of the day.
Yeah.
I'm still a big fan of it.
Yeah.
Now, we don't always have a choice. Like, industry is going to make what industry makes.
Of course.
I mean, even like the advancements and changes we see, it's really just slightly electrifying or slightly modifying most of those simplistic devices.
Even
when
like
you
a
look
quick
at-
take-up master.
Yeah.
It's still really the same master. And then with like when we had Gen 1 ABS in the early to mid 90s, the biggest complaint with that was the intense pressure
kickback.
modulation you feel. Yeah, the kickback, like dashboards would rattle like rims were coming off the car. And that's why, the warnings came out. Hey, keep your foot on the brake, because the ABS really is just modulating the line pressure you created. You take your foot off the master, there is no line pressure on those old systems, right? So I think one of the ways they got rid of that, some better solenoid operation down in the module. But I remember reading at one point, I think it was GM, they'd actually modified the master cylinder with a little bit of valving in front of the piston so that pressure wouldn't directly feed back through the push rod.
Wow.
But still, same old master.
Okay. So, well, you mentioned quick take-up master cylinders, which sometimes I get into, but I'll be honest, I kind of stopped talking about. Do you want to tell us what that is?
Not really. Like we don't see them often. Like so even like when we talk about, again, there's like so much we have to get through to these guys.
Before we get to quick take up.
Yeah, but it's like, where do we cover all this? So, that's like my quick overview for like brakes. We're like, well, guys, what type of brake system do you have? We all have hydraulic. None of us are working on air brakes on our cars. Mm-hmm. You've got hydraulic, but there's something called a drag brake system and a non-drag brake system. And they've never heard those terms. I'm like, guys, you're working on these vehicles. Like, they're not secret terms that are high level. Like, you know what you're working on. And for the most part, a lot of the production cars we see are a drag brake system. And the students, they'll kind of look, and I'm like, guys, you have a car up in the air, there's no faults, you spin a wheel and you hear that light kissing noise. Yeah, and I have to make the noise because they relate to it. I'm like, your pads are in constant contact with your rotor, right? Square cut seal keeps that piston out there. Your brakes are slightly dragging. And then they go, okay, yeah. And then somebody will ask, well, what's a non-drag brake system? I'm like, well, there's an air gap between your pad and your rotors. And they're like, well, why would we do that? I'm like, well, any drag on the wheel, it's going to affect brake horsepower. It's going to affect your fuel economy. Mm-hmm. So then we have a non-drag brake system. And then they go, okay. And usually when I teach the hydraulic aspect, everybody gets, just like levers, they get focused on stronger, stronger, stronger. They always forget about distance of work. I'm like, you've got to remember your master. You guys have seen these things physically. You only have about 1.5 inches of stroke on each of the pistons. So when you step on the pedal, that directly relates to piston travel and moving fluid. If you've got an air gap, you're going to lose a lot of your braking effect covering open airspace, not a lot of pedal travel left. So the quick take-ups at the rear of the master on the primary cavity, they tend to have an oversized area with like an extra displacement of fluid to compensate, so that when you step on the brake, there's that extra volume of fluid to pick up that air gap.
Similar to a accumulator, essentially.
Yeah, it's just an oversized back area where the master meets the housing. So that's why I'll tell them, like, if you ever look at a master, generally the cylinder bore is pretty consistent all the way. Yep. But if you look near the mounting flange, you'll see it's swollen up.
Like a bulge.
Yeah, it's oversized.
Okay.
In the housing. That's usually the quick take-up master, from what I remember. But I haven't taught it in years because we just don't have time.
It's almost also like a non-issue. Like, realistically, unless you're looking at a drag concern, like, it don't... Yeah. It's fine. Like, it doesn't affect the operation noticeably at all. It's more so, those quick take-up master cylinders you use a little bit more in the high end. Your day-to-day vehicles.
The odd mid-range production car had it too. I think it was like Chevy Z34 Luminas.
Okay.
They had like that Codex 3.4 dual overhead cam back in the 90s.
That was high performance. What do you mean?
Yeah, back in the time it was. Yeah. And I think, they want to save every little bit of horsepower they can. Sure, your higher end cars might have it.
Yeah.
But yeah, you got to leave some stuff out. But when we're talking about masters, I accidentally will shoot out, a quick take-up master. And they're like, well, what's that? Yeah. Oh, now I got to tell you what drag versus non-drag brakes.
Yeah.
But I gloss over it.
So in lab, you start in lab. This is your ideal scenario. You start in lab and you hand them a master cylinder, or you do your demonstration. What is the walkthrough of that demonstration then?
So when I have the time in the lab space, I provide them with lab sheets. And my lab sheets, they're in no way collected, graded. It's me helping students make their notes, right? So they'll have a lab sheet, and usually I have like an exploited parts diagram, and then I'll have a whole bunch of open-ended questions that generally work towards how does this thing operate.
Yeah.
So I'll give them a master, I'll give them the tools, I'll give them some safety warnings. But I pretty much set them loose in a group, and I'll say, look, the first thing you guys want to do, you want to disassemble this, and I'll give them precautions, right? And I know they're going to run into a problem with some of those masters, so I leave it till it becomes an issue, and then I stop the class and I go, okay, learning moment, and we all come over. But their priority would be to disassemble it, lay everything out in sequence, individually identify and name every component that's in there, including compensating and replenishing ports. Now that we have working terms, I can start asking you, how does this thing operate? And it's not going to be, well, this thing, that thing. You're going to say primary cup seal, compensating port. But the thing I'm usually waiting on is when they disassemble it. Most of the masters I give, they're just dual stage. They're from like base model cars. So a lot of them will have a little bit of return spring force. So I tell them, you need to depress the push rod before removing the rear retaining clip. And they'll usually get the primary piston out first. And they'll have it on the bench. And they'll be like, it's empty. And I'll go, is it really? And I'll grab that master and I'll look in the bore. And guys, there's still something in there deep. It's the whole secondary circuit, and they can't get them out. So my warning is, these things need to come apart by hand. There can be no physical prodding, poking, anything that will damage the internal surfaces or the suckers.
Long picks jammed in there.
Yeah, no picks, no screwdrivers. So they can't get those pistons out of the bore. So I go, well, guys, you can't physically get in there and manipulate the thing. You will damage it, we'll get it apart, and it's not rebuildable. So, a few will figure out vibration is your friend, and you'll see them tapping it down on either their palm or the wood bench. Yep. And depending what the corrosion is like in the bore, a little bit of vibration and the weight of the piston, it will come out the rear. But when they can't get it, that's the learning moment, and that's where I get my blower, air line, my block of wood, my regulator to keep it no more than 30 PSI. And
why not jack that up to 100 PSI?
Yeah. Pascal's law. Right, if we're going to put 100 PSI behind a half square inch piston.
All right, let's start the math.
Yeah, we're getting a potato cannon, right?
Who's getting hit in the head is what's happening.
Well, so what I would do is, and I said, we're going to, just like transmissions, we're going to use pressure to move internal components in their position, right? Because the stops are out. So we'll put, controlled line pressure behind, but I usually leave all the compensating ports and main lines open so that we can have a little bit of leak down, because it might not need 30 PSI.
Sure. Yeah.
And then, it's not budging. Now we'll start sealing those ports. And of course we got the block of wood there, because when that piston does kind of break free, it does launch, and we don't want to chip it, have shrapnel, get something in the eye. So it's in the block of wood. But years and years ago, when I was a bit more wild, I would have the guys.
When?
When?
Or you mean?
I would have the guys in one corner of the lab, and I would say, guys, watch this. And I would say, we got a piston, secondary piston stuck in the bore, and I would put that blower unregulated, 120 PSI. And I would put it behind there. And
Did you have a target on the other side?
Yeah, other side of the shop. And I'd be like, hey, everybody behind me. And it was just a big thump, and that piston went flying. And I think one day I kind of nicked one of the windows. And that was about the last day I did that demonstration. Because, that thing
That's
used
why the
to
heat's
shoot.
been so bad.
That thing used to shoot. So, once, again, that is a trade tip.
Yeah.
Like,
of course.
You couldn't get it apart. Don't get in there and pry at
and
it,
score
poke
something
at it.
and break
Look,
something.
let me show you a trick. And here's the block of wood. And also, I always hate when somebody knows just enough to be dangerous. I don't want them to remember, put air behind something and hit it.
Yeah.
So I'm like,
We've all
constantly,
done that with water bottles and valve cores.
Yeah. So I'm constantly like, guys, I'm just, 30 PSI, 30. I'm just reiterating it over and over again so that they remember. The most important thing is regulate that line pressure.
Really like that statement too. Knows just enough to be dangerous.
Because they'll remember.
In the trade, it's very easy to know just enough to be a weapon.
Yeah.
So,
It's if I got to stress any detail, I'm gonna stress the regulated pressure. But again, that's why like when that thing shoots out into the block of wood, they hear that loud snap. And I go, guys, that was 30 PSI. Right? Like if that had been more, think of what could happen.
Yeah.
So even that demo, when it's regulated, it wakes them up. It's a snap. It's a bang. And I'm like, guys, I want you to remember that. Like next time you're putting air to stuff, things happen quick. So once I get that all torn down, then it's like, all right, let's see how it operates. And I'll go around and I'll see their explanations. And then when I've had enough and they've had their time, then we have the big group discussion. And I'll lay down all the internal components without the outer cylinder, and I'll show them the operation of it.
And that and you draw it on the board too if you have a board behind you.
I draw constantly.
Yeah.
So if I'm in the theory classroom, students are encouraged and they really need to make their own notes. But I mean, I print very little. Everything is drawing. And I think that really, I've always drawn, but when we were on the
COVID,
lockdown.
Zoom.
Yeah. So Zoom for me, I thought it would be a huge challenge. One, I can't see the guys.
Yeah.
There's not that social connection. But also I draw like crazy. I don't, assign work from the textbook. I don't read PowerPoints. I use the projector only on day one to show the course outline and go over it. And then I even tell them, guys, you'll never see me turn this overhead on again. My PowerPoints, I'm not going to read them to you. You can do that on your own. Like, take advantage of me. So what I started to do with Zoom was I just opened up shared screen and I got out Microsoft Paint. And I was just drawing as best and I got really good near the end.
Yeah.
But I would draw what I did freehand. And I would save them as the notes, because as I drew, I figured, you know what, I can type on it also. So I'd write down like master equals FROP. And then if we were talking about something, like somebody said, well, sir, what about dual piston calipers? I'd be like, oh, and I'd make a little note with my drawing. And then I didn't even think of it. One of the students said, can I have a copy of that? I'm like, you know what? I guess I did draw it all on a computer. I can save it.
Yeah.
And I've actually started using that even now that we're back at the proper swing. I have digital images of what I draw with notes, and I make it available on my course shell.
That's great.
So the students still, though, they still make their own drawings, because there is something to be said for you physically doing it and retaining it.
Yeah, we've shared students the last year, and I look at their notes a lot. I walk around and I'm like, oh, let me see your notes, and I see a lot of your drawings mimicked, and the good students have all those drawings down with the stuff, and they're studying it because it makes a lot of sense.
Yeah, so I'll put the digital
really
copy
good.
up, because some of them say, I'm not a very good artist, and when you're doing it, my drawing's a mess. I say, well, no problem, man. Like, I'll post my stuff.
Yeah.
But then I'll walk around too, and sometimes I'll see students that were taking notes, and their images are nicer than mine, and I'll pretty much take them away from that student. So what, you're shading? Like, you can't be doing that, man.
So 2 tips if you're in D'Amico's class is A, those lab sheets are super important. Don't just go, what is this crap?
Yeah.
Pay attention to them, because they'll help you pass the course pretty much.
Well, all the lab assessments are lab quizzes and a lab final exam.
Yeah.
Like, if you've done your lab sheets, they're your notes.
And take good notes with drawings. So a couple tips for D'Amico.
Bring your pencil crayons.
Also-
or just crayons.
Yeah. Also, try not to be taller than me. That kind of irks me a bit.
Is that my problem with
Yeah,
you?
I just
No, okay.
slouch.
Oh, sorry.
Okay, so is there any other aspect of master cylinders? Well, you know what? You mentioned the compensating port and replenishing port, but we didn't talk about their purpose.
Yeah, it's going to be hard for me to explain without drawing. We're on a podcast. So we've got that. We've got a piston, master cylinder piston. I'll just pretend it's a single stage because it's just
that
repeated
works.
for the secondary. So I've got a piston. I've got my area in front of the piston that contains fluid, and then I've got a line down to my slave. But what's going to happen is we like to have free play in our pedals, and we on any control, right? Because we need that feedback. We also like to put our foot on stuff, right? Like a lot of times you don't even think about it, but you are moving your foot to the brake pedal, but you don't actually want to brake.
You're getting ready in case.
You have the intent that I might need
Sure.
to. So what's going to happen is the master piston is going to move a little bit. Well, according to Pascal's law, if we put any force on that, even a pound, it's going to create mainline pressure. You already have a drag brake system. You put a few PSI behind a slave piston, your brakes are kind of working. They're not being effective, but they're heating up, right? So what we have is in that cylinder bore, and I kind of relate it to the students, kind of like a 2-stroke engine that has no valve train. The position of the piston opens and closes some ports. So we have a port in the bore ahead of the piston that should that piston move, fluid is not going to be pressurized down the main line to the slave. It's actually going to go up that compensating port into the reservoir, which is just atmospheric pressure. So the fluid can move into an area. We have not created any mainline pressure, but should we push that pedal a little bit further, we now cover that effective leak in the cylinder. Now we're going to start pressurizing down to the slave. So that's one of the things I'll let the guys know. And then when we talk about, like, as you're aware, like level 3, push rod adjustment, right? If mechanically that push rod is, and the biggest concern, I would always say too long, right?
Yep.
You're going to assemble the master in an applied position, right? It's going to move that piston, block that compensating port, and it's like putting a thumb over a straw. You've trapped it. So it kind of relates to that.
Absolutely.
Which I think I might even talk more about masters in level 3 than I do level 1.
Really?
Because when we get into ABS and all that push rod adjustment, it's the throwback.
It's nice, Will, and theoretically they have the understanding of it already, so you can kind of just start picking up where you left off.
Yeah, I've kind of I go under the assumption I give them credit. I'll do it for alignment all the time. I'll say, guys, I know you were taught this in a previous year. Is it safe to say it went in one ear, didn't even bounce around and out the other? Like, let's just cut right through the smoke. And they're like, yep. I'm like, okay, good. Let me get you up to speed real fast so we can do the next better thing. But yeah, I'll never just say, you guys, you learned this. And everyone will say yes. But if they don't remember any of it, you can't do what you're going to do. So yeah, you got to take the time, even if it's 10, 15 minutes.
Just to recap, and
just to the
a lot
focus
of them
points.
I do find will, once you talk about it for a couple minutes, they'll
Pick it up quick.
start to they'll recover it and continue.
Or at least the points you want them to remember that apply to what you're teaching now.
Yeah.
Like, let's not redo the whole thing, but try to remember the compensating port because we're talking about push rod length.
Yeah.
Yeah.
And then the replenishing port.
Yeah. So the funny thing is the replenishing port, so when we're on the return stroke, I've taken my foot off the brake, you got the return springs, but you got fluid behind the piston also.
Yeah.
While a spring returning the piston, springs apply mechanical force. You're putting force to a piston with fluid behind it. You're going to create pressure on the backside. You'd get brake lag. That as that piston's trying to return, your foot's off the pedal, you're waiting to displace fluid. So that's why we've got like our cup seals that will tip forward, right? Effectively, it's a piston without a ring. It'll travel back further. And then we have that replenishing port on the rear side, giving that fluid somewhere to go. Go up to the reservoir. I don't stress the names too much. Like when I teach it, behind the piston face is the replenishing port. In front of the piston face is the compensating port. If you look at other manufacturers, they'll have a million different names for those ports. And the worst one I found is another manufacturer of a master will use the exact same terms, compensating and replenishing, but they switch the positions.
Yeah.
That's the word. It's not even a different name. It's the names you know in different spots.
It's like they just had a bad image and flipped it.
Yeah, exactly.
That's kind of effectively what it is.
Yeah.
So I never bust their chops on the naming when they're trying to find it on their own.
Sure.
But I make sure to square them up by the end of lab. I'm calling the one in front of the piston compensating port. I'm calling the one behind the piston replenishing port.
Great.
And that makes it fair game for testing. In reality, they still know what they do regardless of what they're called.
Yeah, I think a
That's
lot
a
of what
win.
we teach, we always preface that realistically in industry, manufacturers are going to use 30 different terms. And sometimes with one manufacturer, they'll use different terms model to model for the same thing.
Yeah, it really
Right,
depends
so-
what it is. Like masters have been pretty good for primary, secondary pistons.
Yeah.
Not a lot
Yes.
of screwing around going on
Yeah.
there. But yeah, some of the other things like suspension parts.
Oh my, multi-link.
Yeah, like you can have what I would call. I'll take it right from Honda's playbook. They have a strut rod, lower control arm, forward two frame, strut rod. A lot of Audis, Beamer, everything. They all have a similar suspension, and they have a million different names for them. Dodge, tension strut, compression strut, tension rod, compression rod. It's like, oh man, there's too many names for that one part.
Yeah.
And it does overwhelm. Like, but if we're testing, which we do, right?
Let alone a lot of manufacturers call it a control arm. They just
Just
look
any
it up.
arm.
They just call it another control arm.
Yeah.
Yeah.
Just any arm.
Yeah.
So yeah, for us though, the trick is we got to be fair to the learner.
Set a term and stick with it.
Yeah. Don't keep bouncing around between the 10. I maybe acknowledge them at one point and say, look, here's all the different names I know.
As faculty, it's hard sometimes because we need to also follow what's on the CFQ. They need to pass a ministry standard. So, what terminology is going to be the correct one. So when I first started here teaching, I screwed up case carrier and the differential. I was teaching level 2 drivetrains and I'm like, oh, that's this. And then, but that's what Dodge calls it, not what the book calls it. I was like, shoot, don't listen to me guys. Just this is this component.
Yeah.
So,
I'd like to say that the CFQ probably isn't as word sensitive.
yeah, that's a good
They're
point.
not giving you like similar terms for the same thing in the question.
They're giving you a component to
Yeah.
yeah, exactly.
Like they're just going to be like hardcore. Like the most likely cause is a problem with the carrier, a wheel bearing, a rim,
exactly.
or a spark plug.
Right,
Like,
Or a spark plug. Definitely the spark plug.
Yeah, I'd like to think they keep their possible answers
Yeah, that's true.
so far apart that even if you had a different term from a manufacturer,
Question was, there's a vibration.
yeah,
Spark. Well,
misfire, right? There you
Misfire.
go.
the above.
misfire under acceleration.
Yeah, E, I'm making my own. Anything you want to add on with that, Harnick, about masters?
Yeah, what do you do with your masters?
we hit a lot of the points. So I do it with less drawing because I can't draw worth a damn.
Yeah.
But I do like a lot of stuff I find when Jay talks, I'm like, yeah, I do it similar. But, and again, when it comes to the math, I'll go over the math a couple times and then I'll go, do you think when I'm trying to diagnose a car, I pull out a piece of paper and I start writing these numbers down? No, I just have to understand the relationship of the formula and how, whether it's kinetic energy in level 1 or whether it's, force, whatever it may be. I don't care about the math all that much. I just need to understand the relationship between these principles and how it's going to react and how it's going to operate. Right. So I don't go too far into it with drawings and that kind of stuff. Again, just because I can't draw. So I do turn the projector on and I show them pictures.
Oh.
Okay. So we do look at those instead. And then I try to talk it out as much as I can. But just focus on really the basics. Yeah.
There's one thing I wanted to cover too, and it's so you talked about a single master, and then you talked about a dual master,
Okay.
and then also the configurations for those and why it's important safety wise. Do you kind of want to get into that a
I'm
little bit?
going to have to remember a
Well,
date.
you know
here,
what I
right?
like to do?
dates, forget dates.
I
No, it
will-
was about 56, I think.
Sure.
So
Yeah.
we always had, and I always tell the guys, like a single stage master, one master.
Yep.
And then again, from our hydraulics talk, right? Pressure is equal in all parts of a sealed container.
Exactly.
So
And that's where, I'll cut you off for a sec.
Yeah.
That's where then I like to show a picture of a leak in the hydraulic system. And I go, why is this a bad system overall? What's going to happen to pressure in the system?
In a
if there's-
single.
In a single,
Gotcha.
right?
Yeah.
So I was like,
Yes.
why did we move away from this?
Yeah.
And then if they understood what we were talking about with, all that theory, then
Yeah.
they know where the obvious problem is now.
yeah, the whole system's compromised
Yeah.
is what you'd like to hear.
You
Don't
better
always-
have a
yeah.
e-brake or a handbrake.
Well,
at that
so
point.
that's what we had a single stage master, and then that one line teed off in 4 direction
Yes.
to 4 slaves, and usually it was 4-wheel drum brake, right?
Yep.
And I'll tell the guys, this system sealed works
Great,
mint.
works great.
But then I'll go to my drawing and I'll just break a line, draw some little drips.
Yeah.
Fluid comes out, air goes in, whole system's compromised. So, and I'll say, like, these are before your time. This is where the master cylinder, you're actually stepping on the brakes. It was down at the bottom of the firewall. And, they can't relate because of their age. But yeah, last intake, I had one student, he goes, yeah, I got that. He had some old 50s car.
Oh, cool.
There's always like a guy.
Yeah, I'm
Yeah,
like,
yeah.
well, he's only like a 20-year-old kid. I'm like, okay, so this is your dad's car or uncle's car. I gave it to you. He goes, no, I went out and bought it. I'm like, wow, you're the coolest kid I've met today. So yeah, he had that. So he had the single stage, and then I think it was like around mid 50s America, because we just copy them, right? By law, you had to have 2 hydraulic circuits in case there was a failure, and then 1 redundant mechanical at the time, right? So that's where a dual stage master, and I'll even say, like, you could have 2 single masters side by side with some kind of crossbar going to a pedal assembly, or 2 masters in 1 common bore, 1 piston in front of another piston.
Yeah.
Right. And then I even explain in the lab when I get them going for the operation, the primary piston is applied mechanically, the secondary is applied hydraulically.
Yeah.
What happens if we have a fault in the primary circuit? Then they'll say there's no brakes.
Yeah.
I'm like, well, that defeats the point of a dual stage master. So what'll happen is that primary piston actually has, kind of a push rod in front of it. So should we have no fluid in there, the primary piston is applied mechanically, but there's just air. But it will bottom out and hit the secondary.
Yeah.
So normal operation.
Actually, I was going to ask you about that. So I like that little statement that you say that, and you do that well in lab. So if you have D'Amico 4 SSB, listen to that component.
Yeah, I'm electrical now, so I'll never have to talk about this again.
Actually, there's a spot open in day release. That's
Yeah, no, sorry. Yeah, so I kind of just always reinforce, normal operation, primary piston is applied mechanically, secondary piston is applied hydraulically.
Yeah.
In the event you lose primary circuit pressure, primary piston is still applied mechanically. It's not doing anything, but it'll bump into the secondary and apply the secondary mechanical wise.
And that used to be split in two different ways, right?
Yeah, well,
Front
and
and
then,
rear.
yeah, again, in level 3, I'm kind of revisiting this because we're getting into our ABS, and I'll teach them about front rear splits and diagonal splits, and then I'll even get kind of spicy and put up the left right split, which I go, and they'll go, okay, that makes sense. I'm like, nobody does that, guys. It'd be a skid steer.
Yeah.
Yeah.
So that's actually never an option. So yeah, then with the front rear,
Yep.
70-30, and then that leads us into brake biasing, and some guys will talk about brake biasing.
For
and-
sure.
Yeah.
And then, it kind of wraps up too with the stuff you start with in level 1 where you talk about dynamics. And
I kind of bring it all right-
exactly. That's
See,
what I
this
like
is
to do.
how it
Right at
all
the end, you
works
kind of
together,
bring it all.
yeah.
It's
Yep.
good.
And maybe some light bulbs come on and go, that's why we learned about it. Yeah, man, it's a whole package. We just can't teach you start to finish right out of the gate.
Yeah.
The way we're set up is, 2 months of schooling once a year. But yeah, year 3,
Not for you. It'll be one day all year long.
yeah. Yeah.
Awesome. I think that wraps up really well. I was excited to, after I sat in that lesson with you, I really was like, we got to get you on the podcast talking about this because you just
It must
explained
not have been
so
good because I'm
well.
back in electrical. Out of SSB, I got fired.
We do have 2 new questions for season 2. We've been all over the place, but the first one, if you had one meal to eat,
What would it be?
Well,
What
last
would it
time
be?
you guys asked me these silly questions about my favorite suspension, I got the answer wrong. Harnick pointed out a better one. Favorite food, I got to go with that staple that's never wrong, pizza.
pizza
All
is a
right.
good
Got-
call.
it's gotta-
Now, do you have pepperoni or
Yeah.
pineapple? Do you have pineapple on
I,
your
w-
pizza?
I will, but
Okay.
when I'm in the mood, but it's got to be, I won't put it on just any pizza. What is it, the Hawaiian?
The Hawaiian,
Pineapple,
okay.
ham,
Yeah, that's
maybe bacon. That's the only configuration I see it's appropriate for.
pizza's a good answer. It's
It's a pretty solid
generic.
good.
Yeah, it's also
Yeah.
a cheat food because you
Yeah.
can put like 20 different toppings
Yeah.
on it, right?
Yeah.
But yeah, it's like straight up pepperoni.
Well, what's your favorite pizza then? Because
Pepperoni.
there's like no. What
just
about like
straight
your favorite
pepperoni?
pizza joint? Like, where's the place to go?
Are they going to be hearing this and we'll get
Maybe.
Yeah,
let's
cards,
go.
maybe a hat, a t-shirt? Depending on the mood, I guess I like consistency, right? So I'm going to have to put probably Pizza Nova. It's got to be my consistent go-to.
Completely agree.
But I've gotten really into everybody makes like some really super thin pizza now. So like Pizza Hut, Domino's, those thin pizzas.
Yeah.
That's kind of my go-to.
Okay.
But yeah, if I had to like gun to my head, snap decision, Pizza Nova can't go wrong.
Yeah, I agree with that.
And they carry brio.
Okay. So I guess our next question is: if you could go anywhere, you spend some time on vacation or whatever it is, check out
Anywhere
where
in the
would be
world.
anywhere in the world. Where would you go?
I think Gully said anywhere with you.
That's
I have to take him with me?
you
No,
don't
no.
have to take him.
But he may show
Is it
up.
like carry-on luggage?
Just be aware he may show up.
Surprisingly, I have no interest to go anywhere.
Really?
Yeah. Even when I've been on a plane like twice in my life. Like, so I've been there, done that. Good enough for me. But like the motorcycle, when I used to cover like 1,200 kilometers a day, I didn't care where I was going. It was about getting there. Like I even rode down to Boston
Well, then
once for like
this
5
kind of
minutes.
goes to the level 2 guys we were talking about. If you could ride any place in the world, is there a spot you would choose?
Yeah, see, now I'm thinking kind of like that Australia outback
Okay.
adventure type ride.
Yeah, like a Baja kind of
Yeah,
thing.
even like blast around like Vegas or Arizona. Like these are attainable things for me. I can make it there.
Yeah.
Just lazy.
Okay.
But
So,
yeah,
but you want to be on a bike or on a ride? or
Yeah,
something
kind of
like that.
kind of like a cowboy thing, except you're on a motorcycle, not a horse.
Okay. Like
Just bombing around. Maybe rob a stagecoach. I don't know. We'll see how I'm feeling.
I like that.
Yeah.
Awesome. Well, thanks for coming back
Oh,
on.
thank you guys.
Thanks for coming and chatting about Master Cylinders. And yeah, we got to get you on again. Alistair's
We
in,
really
Alistair's in
Alistair's in this
competition with
race
you.
with
He's
you on who
yeah.
can be the most.
So you've tied up with
consistent.
Alistair
but you
now,
make it
and
sound like
he's-
we're voluntarily having a competition here.
I mean,
Oh, well,
we-
Alistair's definitely like, I
volunteering.
got it.
Yeah, he's
I'm
volunteering.
dragging you in.
Yeah, he's such a suck up, that guy.
all right,
He's
man.
at the door now. He's ready to go for the next one.
All right,
Sorry,
dude.
we're cool. All
Thank you so much.
right, thank you guys. Good
Jay.
talking to you again.
This has been the Talking with SOT podcast with Harnick Gill and Ian Campbell. Thanks for listening.